All right, before you do your first proof, we're going to need some help, all right? Because, and this is no offense to you, your knowledge isn't good enough, all right, of geometry yet. Your knowledge of all the vocabulary terms isn't good enough to do a proof. We need some extra help to do the proof, all right? So I'm going to show you 3 things that are going to help us complete a full proof here today. First one, I'm not going to spend too long on it. It's called the reflexive property. And you'll start noticing I'm going to put these up on the board here as we discuss them. All right, I did it first period, so that's why they're up there already. Those will be up there for your quiz or your test next week, and I will provide all of these on a sheet of paper for you as well. So there's no need to memorize it and how to spell it. So the first one that's going to help us do these proofs are called the reflexive property. And I know you're looking at this underneath it and being like, really? A quantity is equal to itself? So if I draw angle B, it's also equal to angle B itself. I know this sounds confusing. It's like, duh. All right, it's equal, AB, a line segment, is equal to itself. Trust me, you'll understand how we're going to use it at the end of the period. All right, but for now, that's what it is, reflexive property. All right, substitution. You did this in algebra last year. Take a look. Find 2x minus 3 if x equals 8. What'd you do with that 8 last year? You took it, and anywhere you saw an x, you plugged in 8. So you did it for algebra last year. We can do it for geometry too. Take a look. I did a statements reasons for you already. AB, the length of AB is twice the length of AD. All right, let's get that. AB, twice the length of AD. AD is also equal to DB. Wait a second. AD equals DB? So anywhere I see an AD, what can I put in its place? And then everyone's seeing the first statement in AD? So I could take DB and substitute it in to write a new statement. And what's that new statement say? Oh, AB is also 2 times the length of what? Substitute it in. It's 2 times the length of 18. Who's got 18? I don't have my sheet on. 18? Cormac? It's twice the length of DB. What gives me the right to put DB in there? They're equal to each other. So anywhere I saw an AD, I substitute in DB. Everyone see the substitution B. It's just not numbers. It's a line segment now. You and your group right now. Next one. I'm giving you angle A plus angle B. Remember the M means measure. Equal to 90. A and C are equal. B and D are equal. Can you guys in your group come up with 2 statements that are now true using substitution? Go ahead. See if you and your group can come up with 2 statements that are true using substitution. A plus B equals 90, but A and C are equal, B and D are equal. So write 2 statements for me that would be true because you substituted in. There's actually 3 statements we could have, but I only want 2. And write those in, statement 2 and 3. Substitute in for what it's equal to and rewrite it. Oh, let's get the first one down. 12:05. Start us off right here, Jared. You got 1 statement using substitution that has to be true.
MC plus MD equals 90.
Okay, so you're doing angle C plus angle D equals 90. Perfect. Jared just went hardcore on me. He did the double substitution. All right, he just said, all right, anywhere I see a C or anywhere I see an A, I'll plug in C. Anywhere I see a B, I'll plug in D. So he just doubled up on there. That's fine. I could also do it just once, though. Give me another statement that must be true other than angle C plus angle D equals 90. He did a double substitution there, which is fine. 10. Woo! Henry?
The measure of angle C plus the measure of angle B equals 9.
Okay, yeah. Here's what Henry, he said, hey, angle C, which I can plug in for angle A, keep angle B, don't substitute in for it, equals 90. And the other one, anybody, if you had was correct, was angle A plus angle D equals 90. So does everyone see the substitution working now? All right, a little piece of advice. How do I know I'm going to need substitution? Repetition. I have no idea if that's how you spell it, and I don't care. Repetition of angles or segments. Okay, that's how you know you're going to use substitution. Is angles, what do I mean by repetition? Look at number 1 here. Everyone see how AD appeared twice? Look down here. Everyone see how angle A appeared twice? Angle B appeared twice. All right, so if you see repetition in the givens of a segment or an angle, I'm probably going to substitute. All right, probably going to substitute. All right, so we have reflexive, which we have that's an unknown right now. We don't know how to use that. Now we have substitution. Last one I'm going to show you today that's going to help you on your proofs. It's called addition. And you don't need to copy this down here. I just want to make my point before I show you how this works. Okay, I have 4 line segments up on the board. A, B, C, D. 4 line segments. Ready? I'm going to tell you A is congruent to line segment B. All good. And I'm also going to tell you line segment C is congruent to line segment D. All right, so everyone sees I got this pair congruent and another pair. If I put those 4 line segments in front of you right now and ask you to put A and C together, boom, put them together. Makes a longer line segment, doesn't it? If I put A and C, everyone agrees, makes a longer one. And I ask you to put B and D together, put them together. Makes another longer line segment. What do you now know about those 2 longer line segments in front of you right now? If I put A and C together, that's in front of you. B and D together, that's in front of you. What do I know about those 2 longer line segments? They should be congruent, the same length. Everyone agree? They should. Okay, what if I put A and D together? Or B and C together in front of you, what are you going to know? They're also going to be the same length. Why? Because of what's called addition. All right? If you have 2 pairs of equal quantities, and you add them together, the results are also equal. This is called addition. All right? I add 2 pairs together that are equal, the results will be equal. All right? So a number 1 here, basically I have A equals B, C equals D. By addition, I could say the following. Ready? Add A and C together, and we've already done this. That's the same. That's equal to adding which 2 together? B and D. I'm not done. Give me another statement right below it that also would be true if I added them together. Yes, if I added A and C together, that's the same as B and D, but I could also add, here we go, what other pairs together and it still would be equal? $17. What other pairs here? Dylan, what do you got for me? A plus D is the same as if I added what? B plus C. Perfect. But if you're going to add, you need 2 pairs always. Okay, you need 2 pairs to be equal to add. I'm going to sound like a broken record with that today. Oh, you want to add? You got to have 2 pairs to add for me. Not 1, 2 pair. All right, I'll give you a sec. If you need to stretch out, do whatever you need to do because you're about to have a big moment in your mathematical careers, and I'm talking K through 12, not just high school mathematical careers, because we're about to do your first proof ever. All right, about to do your first proof ever. This is a big moment in your mathematical career. Soak it in, big deep breath. Let the magic happen now. All right, we're ready for your first proof ever. You've grown up. First, before we get into it, let me tell you the details about a proof, because this is one of many you're going to see through the course of the year. This isn't new, right? You had that yesterday. This is true statements. True statements that you should be marking on your diagram. So AB equals DE. Everyone go to your diagram, and what should I be putting on AB and DE to show they're equal? Hash marks, yeah. Let's act like we've been here. So on AB, hash mark, hash mark. I've also given you a second given. What should we be putting on B, C, and EF on my diagram? No, but probably 2, right? So it doesn't look like all 4 are equal. All right, good start. So every proof, I will give you true information. Something you haven't seen yet that you will see in every proof now. This is what I need now. Show me this is true. This right here should be the last statement in every proof. All right, if your proof has 9 steps, it should be the 9th step. If it has 4 steps, it should be the 4th step. All right, that is what you're trying to get me to show me is true. And that should be the very last step in your proof. Okay, the very last step. All right, here's going to be the deal. You need to help me get from here to here using your knowledge and some of the help I've shown you today, reflexive substitution addition. That's where we need to get. Knowing that's true, the givens, show me the proof statement's true. All right, and it's just not going to be 2 steps and I'm done. So how can I get to those givens being true to the proof statement? Well, let's take a look at the diagram to help us out. Everyone sees what you got marked, right? How do I get to AC on that top segment then? What am I going to have to do with the AB I marked and BC that I marked to get to AC? And don't make up something on your own. Think about what we've talked about already. What am I going to have to do here in this top segment to get to AC? What am I going to have to do here to AB that I marked and to BC that I marked? What am I going to have to do to those two to get the whole thing? I'm going to have to put them together, AKA put them together, add them together, right? And let's go down here. What am I going to have to do to DE and EF to get to DF, which is in my proof statement? What am I going to have to do to those two? Well, you want to add? You want to add? You better have 2 pairs of equal quantities. Did I give you 2 pair? Look in the givens. Did I give you 2 pair? Okay. Can we count to 2? What's going on? How many pairs did I give you here? 2. So you can add. All right. You can add right now. You just have to tell me what you're adding together. So in statement 2, we've already said, all right, we got to add. But now you have to write and tell me what are you adding together. All right, because you have to add certain pairs together now. All right, let's go to the first segment above. Tell me what you're adding together so I can write that down. What 2 segments are you adding together to get to AC? Because that's where I need to get to. What 2 are you adding together to get to AC? 10. What are we adding together here, Henry? AB plus BC is the same, equal to, adding, go to the next segment. What do you want me to add in the next segment? 11, Micaiah? DE plus EF I'm adding together. Why is this a true statement? Don't make something up. What did we just do to them? I'm adding them. Addition. That's why it's true. Addition. By addition. When I add 2 pairs of equal quantities, the results are equal. Is that what my proof statement looks like? That means we're not done yet. Remember, last statement is always the proof statement. All right, so how do I get there? Give me another name for AB plus BC. Look at that diagram. Give me another name for if I took AB and added it to BC. Give me another name for that then. That's the same as doing what? 14. Give me another name for it, Stephanie. Watch. AB plus BC is the same as if I plugged in AC. Good. Nice. And then go ahead, keep going, Stephanie. What about DE plus EF? That's the same as if I put in what? And why can I do that? I plugged in the same thing. What's that we talked about already today? That's all I did was substitute in AC for AB plus BC. Substitution. Is that my last statement? Yep, that's what I needed to prove. So I added the equals together to get to the full ones. That's how I did the proof here. And notice, I should have mentioned this at the beginning. I already wrote this in for you, but that's got to always be step one, right? Is your givens. Always step one is your givens. One doesn't make you great, and we're going to do hundreds of these this year. But your first proof here. Anything we want to discuss here, your first proof, congratulations. Pre-pouch days, I take a minute or two right now for you to get your phones, take a selfie with it, so you can pop it all over your socials and say, hey, my first proof ever. So you can document this moment, but that's no more, unfortunately. Maybe later on tonight you can do it. Questions, comments? All right, like I said, we're doing hundreds of these. We're not even close to done. Let's go. Next one now. All right, so let's get in this habit. Read your givens, mark it in your diagram, and write your first statement. All right, let's get in that habit right now. So read what I've given you, mark it on your diagram correctly, and then write it in your statements. That should be statement number one, given. What are you putting here on those angles? If two angles are equal, how do you show that on a diagram? Arc marks, hash marks are for segments, arc marks. I'm hoping you guys can find these angles here. ADF, follow the letters. Follow the letters to see what angle it makes. Mark it with an arc mark. CBE, follow it. C to B to E forms an angle. Make sure you go in the order I gave it to you. I'm going to walk around before I do it, making sure you can find them. Talk with people in your group too to make sure you guys can all find the angles. Let's see if we can find the angles. Good, good. Don't mark, never mark the prove angle. That's just going to get confusing. That's what we're trying to show is true. We only mark the givens. Only mark the givens. Do not mark the prove angle. Good job, everyone. Oh, we're missing the angles. We're missing them. Some of us. Follow the order. Follow the order. Get rid of that bad boy, right? Or that. All right, it should just be those two and those two, right? So those two are equal, those two. Good. Good job, guys. Good job. All right, for the most part, we're good. Hey, we should be having, ready? The first pair, ADF, is this angle with CBE. So those should be marked with either one or two arc marks. And then also EDC marked with ABF, those two. So everyone's got the correct markings first. All right, now let's look at our proof statement, what we need to accomplish. ADC, don't mark it, find it though. Find it. ADC, everyone see that angle? This one right here, the big dog one right here, ADC. Oh, wait, whoa. Look at, right now, ADC, and look at you have markings right next to it. What would I need to do to those two angles there to get to that big angle I just marked? Oh, Adam, maybe this is an addition one again, huh? Over here, we need to make ADC equal to ABC. Find ABC right now. Find ABC, everyone. Everyone see that angle? Oh, look where it conveniently is. What do you think I'm going to have to do to the two given angles to get to ABC? Put them together. Adam, does everyone see the addition? Do we see it or no before I move on? Do we see the addition? All right. What do you need to add? How many pairs? Two. Look in the givens. How many pairs did I give you? Two, so we can add right away. All right, I gave you two in the givens, so you can add them right away. It's just a matter of name the angles you have to add together to get to the full ones. Okay, here we go. I'm going to ask somebody right now, name a pair of angles that you need to add together to get to either ADC or ABC in the proof statement. So give me a pair of angles to add together. Let's do this. 21, going deep. Lauren, give me a pair. ADF. Okay, hold on. I got to go slow here. ADF, good. And you're going to add that to? EDC. Great, EDC, yep. These two right here. Bottom left. Nice job, Lauren. ADF plus EDC is the same as adding 9. Ooh, Vinny?
CBE.
Okay, good. With?
ABF.
Good job. These two added together is the same as these two added together. That's what we just wrote in statement 2. Because of what reason? Addition. That's not my proof statement, so I'm not done. So in step 3, give me another name for ADF plus EDC. Give me another name for that. If I take angle ADF and add it to EDC, give me another name for that angle. 3 going over here. What do you got here, Stone?
ADF plus what?
ADF plus EDC. What can I put in its place now?
ADC.
ADC, great work. Is the same as, now somebody replace CBE plus ABF. That's another name for that. 1-5. Alexi? ABC, good. And what gives me the right to do that? All I did was substitute in. And yes, if you're starting to pick up a pattern, anytime I add, I probably will substitute right underneath it. And I know this is like, oh, all I do is addition, substitution. Oh, do you really? Well, let's look at number 3 now. Everyone thinks they have this down, the code broken. Not yet, you don't. Mark your diagram, write it in the givens. All right, write your givens in, mark your diagram. Do not mark the proof statement, remember, just your givens. All right. DE congruent to BF. And everyone look at the proof statement we need. I need to get DF equal to DE somehow. All right, let's talk. Everyone has the line segments marked with hash marks. Good. All right, my first question, and we already know the answer today because there's only one thing we've been using, but tomorrow that's going to change. As I go from the givens to the proof statement, everyone look, the given segments to the proof segments, are we getting bigger or smaller? So as I go from DE to DF, as I go from BF to BE, are we getting bigger or smaller? So we're getting bigger. Everyone agrees? Those line segments are getting bigger. And the only way I get bigger is if I add on. So this is going to be an addition one, but here's the catch right now. You want to add in statement 2? How many pairs of equals do you need? 2. Look at the given. How many did I provide on this one? Yeah, you can't add right now. Right now you can't anyway in statement 2. We cannot add. Everyone see why? I have nothing to add to them. Nothing to add to them. All right? But you can find what to add to them. Look at the diagram. How do I go from DE, the one I'm given, to DF, the one I need to prove? What must be attached, added on to it? DE to DF. What must I add on to that segment to get DF? Help me out. 1-4. Stephanie, what must I add on? Everyone agrees I must add on EF to it. All right, I'm just going to write that off to the side that Stephanie said that I have to add on EF. All right, what about the other pair? How do I go from BF to BE in the givens? Look at, how do I go from BF to BE? What must be added on there? 16. Bryson, what do you have? I'm going from BF to BE in the proof. What's got to be added on? BF to BE.
You have to add E.
E, well, E is a point. I need to add on a segment, right?
Oh, okay, so yeah.
So what I just heard from 2 people was I need to add EF to both of these, right? What do I know about EF and EF? They're equal to each other, right? Because of, here's where reflexive comes into play. All right, it'll help me get that second quantity to add. All right, so EF is equal to itself. EF, yeah. By, what's the reason? Why is a quantity equal to itself? Reflexive. That's where this is going to come into play. Now, how many equal pairs do I have written down? And now I can do what? Add them together. There you go. All right, I can add them together. Let me know what you're adding together, please, in number 3. 9, what am I adding together, Vinny?
EF and DE.
Okay, EF plus DE. Keep going, Vinny, is the same as?
BF plus EF.
Good work. I needed help. I did not automatically provide you with 2 given or 2 equal quantities. So you needed to find the other one on your own before you added. Addition. And then what do I always follow this up with? Substitution with what it's equal to. DF equal to BE, my proof statement. So it's always not going to be given addition substitution. You have to have 2 pairs to add together. Go to your homework. I want to make sure you get off on the right note. First thing, I'm going to eliminate one of the problems. And which one am I going to eliminate? 8. Do not do number 8 tonight. Okay, do not do number 8. Go back to the beginning, numbers 1 through 4. All you're telling me is which one of these 3 we talked about today are you using? It's not a statement's reasons, all right? Numbers 1 through 4. Which one of the 4 am I using here? Or which one of the 3 am I using? Excuse me. Once you start on number 5, okay? Once you start on number 5, see, write a formal proof. Now you're going to go the 2 columns for me that we've been using. All right, starting with number 5. And just so you get off on the right foot, let's talk about number 5. Because I know many of you, and this is my fault, are just in, oh, it's always addition. It's always addition. No, it's not. It's not always going to be an addition proof. And number 5 is an example of that. Look at the givens. NP equals 2 inches. QR equals 2 inches. Why is NP equal to QR then? It's not you're not adding anything together. You see repetition? You see the 2's repeat? So what's this proof going to have in it? Only what? This is only going to have substitution. because you're taking QR, and where you see a 2 inches, you're going to substitute it in. So don't automatically think it's always addition. If you see repetition in your givens, it's probably only substitution. All right, go ahead. You can talk with each other about it, whatever you need to do.